The following 4 scenarios outline when a limit does not exist. Notice the limit of the graph as x approaches 0. If we take the limit as x approaches 0 from the right of absolute value of x over x, as our x values are getting closer to 0, our y values are approaching positive 1. If we take the limit as x approaches 0 from the left, the other one-sided limit, our y values are approaching negative 1. And we say approaching those two y values because we can't on this graph land on the x value of 0 because the function is undefined when x is 0. You would have a domain error or a divide by 0 error. Hence you have a hole on the graph. Back to the one-sided limits. If these two one-sided limits are not the same thing, they're approaching different directions, we would have to say then that the limit as x approaches 0 of our function does not exist when the two one-sided limits are not equal. We must make domain considerations on a graph like y equals square root x when approaching an endpoint on the domain. If we take the limit as x approaches 0 from the right of our square root x function, that's our endpoint on the domain, our y values are headed to 0. However, we cannot approach 0 from the left. There are no x values to the left of 0 in the domain because you can't have a square root of any negative x value and expect a real number. For that reason, we say the limit as x approaches 0 of square root x does not exist. You could think of that as two one-sided limits are not equal because you cannot take one of the one-sided limits, the limit coming from the left of 0. Considering y equals cosine x, as x approaches positive infinity, the function oscillates between 1 and negative 1, never approaching any single value within that range. So if we write the limit as x approaches positive infinity of cosine x, we would say this limit does not exist, and it's due to oscillation. This would be the same thing if we went to the left as x was approaching negative infinity. That limit would not exist. Similarly, the graph y equals sine 1 over x oscillates as x approaches 0. So if we write the limit as x approaches 0 of sine 1 over x, we would also say that does not exist. Due to oscillation, yet this graph oscillates in a much more erratic way. According to the definition of a limit, if the function does not approach a finite value or a fixed value, the limit does not exist. The limit as x approaches some number c of some function f of x equals capital L, then we need the capital L to be a finite number. In other words, the limit must converge to a finite number L. Let's look at the graph y equals 1 over x squared. If we take the limit as x approaches 0 from the right, we're going to get positive infinity. And this is okay to write positive infinity here because it shows us the direction that the graph is increasing towards positive infinity. And that's the same from the left of 0 as well. Both of those are heading to positive infinity. However, in terms of the existence of the limit, since the limit is infinite, the limit as x approaches 0 of 1 over x squared does not exist because it is infinite. The function y equals 1 over x is slightly different. If we're approaching 0 from the right, we would have limit as x approaches 0 from the right, 1 over x. We could write this one as positive infinity for notation and also for direction. When you take the limit as x approaches 0 from the left, we're going to get negative infinity. This goes back to scenario 1 where we have two one-sided limits that are not the same. So we would have to write the limit as x approaches 0 of 1 over x. It does not exist. You can cite the one-sided limits not being equal, but you could also say because the limits are infinite. You must have a finite limit if your limit is to exist.